In this section, we're going to talk all about straight lines, equations that have graphs that are straight lines, lines in the plane. So first of all, we're going to talk about slope, which you might be familiar with from past algebra classes. So if you have two lines, they may be different steepnesses pointed in different directions. We measure that with what we call slope. Okay? We can write that in lots of ways here. It's all basically change in y over change in x, which I have in words. We also have the Greek symbol delta, which means change in math and science. So these two both mean change in y over change in x. You can think of that on the graph as rise over run. The change in y is how much you change vertically in the y direction, and then the change in x, we can call that the run, your rise over run. Formula-wise, these are just labels, but if we label our points x1, y1, and x2, y2, then my change in y would be y2 minus y1 over the change in x, x2 minus x1. Okay? And I say you have to have the change in y on top, change in x on the bottom. These are just labels. It doesn't matter which point you start with that you say is the x2, y2 versus the x1, y1, but you have to be consistent. Whichever y you start with on top, you have to start with that x on the bottom, or you're going to get the wrong sign. Okay? So find the slope of the line containing the 2 points, -1, 3, and 2, 7. So plug into our formula here, change in y. I'm going to start with the point 2, 7 as my, when I do the subtraction, so I guess that's my x2, y2, and I'm going to let -1, 3 be my x1, y1. So I did 7 minus 3, the change in y, is over 2 minus -1. Again, I started with the 7 on top, so I start with the 2 on the bottom. And that's going to give me 4/3. We got 7 minus 3 is 4 on top. The two negatives make a plus, so we get 3 on the bottom. So we get 4/3. And often your slope is not a whole number, and when it's not, we actually prefer a fraction because that tells us the rise over run as opposed to a decimal. Sometimes in application we might use a decimal, but in the more abstract terms we like having the fractions. Okay, we're going to look at some graphs here in a minute. We're going to graph 3 different lines that are all in what we call the slope-intercept form. Okay? If you see an equation of the form y equals mx plus b from this point on, we know that's going to be a straight line. And we call it the slope-intercept form because the coefficient in front of x is your slope. We can see right away what the slope's going to be. And if you plug in 0, you get the point 0b, so your y-intercept is the point 0b. So you can immediately see both of those things, the slope and the y-intercept, when it's in that form. Another form that we sometimes use if we know the slope and we know one point and we want to quickly write down an equation of a line, we have the point-slope form of the line, where if we have slope m and a point x1, y1, which are your actual coordinates, so you'd have numbers on a particular problem, then your equation would be y minus y1 equals m times x minus x1, where again m is your slope, x1 and y1 are a particular point on the line, and then the x and the y are your arbitrary variables that are in the equation. If this looks kind of mysterious, it's really just the slope formula rewritten. If you look back at your slope formula, these are just labels. I can call my second point just xy, and I'd have y minus y1 over x minus x1 equals m, my slope. Multiply both sides by the denominator, and you have the point-slope form of the line. Okay? So let's look at these 3 graphs here. Okay? So I've made these in GeoGebra so that I can show them here on the screen, but I want to think in terms of rise over run. So if I know it's a straight line, I could just plug in a couple of x values, get y values. If I have 2 points, that's enough to draw the line, but I wanted to think in terms of slope and the y-intercepts here. These all 3 have the same y-intercept at 1. That's going to allow me to compare the slopes here. On part A, our slope is 1/3. Okay? So that means we're going to go +1 in the y direction, +3 in the x direction, my rise over run. So my y-intercept is 0, 1, and to find another point, we can go +1 in the y direction, and then +3 in the x direction, which puts us at this point, let's see, 3, 2. Okay? I can keep doing that and get more points. I could back it up. I could go down and back to get a point in the other direction, but I only need 2 to help me draw the line. Okay? So this also shows me if I have positive slope, I'm going up and forward, up and forward. So from left to right, my graph is going to rise. My line is going to rise if I have positive slope. It's going to fall if I have negative slope. If I have -1/3, I could think of the negative as going with either number. I like to think of it as going on top with the y value. I'm going to go down 1 and then forward 3. So for the -1/3, Again, we have a y-intercept starting at the point 0, 1, but my slope is negative 1/3, so I go negative 1 in the y direction and then 3 in the x direction to get another point and draw my line. So positive slope will always rise from left to right, negative slope will fall from left to right. And the bigger the slope is, the steeper the graph. If we have y equals 3x plus 1, again it's going to have that y-intercept at 0, 1, but it's going to go up 3 and then forward 1 in the y direction, or forward 1 in the x direction. That's going to make it much steeper than the 1/3. Okay? So the larger your slope is, the steeper the graph.